So next topic in the robotics and its application course, that is the use of computer vision in robotics. So first we will start with a brief introduction to the computer vision, then its applications in the robotic sector as well as some other sectors. So where we can use this technology. So beginning with the computer vision. So it is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. So this is something which is comparable there with that of a human vision as well, as there also we are having some type of images in our eyes, and from that we get some information or the high-level understanding. So from the perspective of engineering, it seeks to understand and automate tasks that the human visual system can do. This is similar to the human visual system. Our automated system is capable of performing the task. So the scientific discipline of computer vision is concerned with the theory behind artificial systems that extract information from images. So some type of information is taken from the images. Okay, so the image data can take many forms. So it could be a video sequence, it could be views from multiple cameras, so multi-dimensional data from 3D scanner or some medical scanning device. So these are all can contribute to the input for a computer vision system, or they can provide some information. So the technological discipline of computer vision seeks to apply its theories and model to the construction of computer vision systems. The computer vision is concerned with the automatic extraction. So first thing, that is extraction, then analysis and understanding of useful information from a single image or a sequence of images. So even one image or more than one image, they can give some type of useful information to the system. So it involves the development of a theoretical and algorithmic basis to achieve automatic visual understanding. So as a scientific discipline, computer vision is concerned with the theory behind artificial systems that extract information from images. So the images, the data can take many forms. So as just we discussed, so there could be video sequence. Okay, we can obtain the different views from cameras, like or multi-dimensional data from medical scanner, just as we discussed. Okay, so now coming to the section of robotics. So the robot navigation sometimes deals with autonomous path planning, just as we discussed in the previous topic, in our previous video there. Okay, so the path planning is there, deliberation for robotic system to navigate through an environment. So it has to move, go through an environment, and it has to plan a path. In that case, the detailed understanding of the path of the environment where our robot has to navigate, it has to go through. So it has to be something totally known to the robot. So how it can be done? So this can be done using the computer vision system. So information about the environment could be provided by a computer vision system acting as a vision sensor. So this is also a sensor and a much higher sensor, which is giving a large number of data as compared with other sensors. Okay, so it is providing high-level information about the environment and the robot. So there are many kinds of computer vision systems, but the common components present in all of these systems, they include power source, one or more image acquisition device. So this could be a camera, processor, control and communication cable, or some kind of wireless interconnection mechanism. So in addition, a practical vision system contains software as well as a display in order to monitor the system. So vision systems for inner spaces, as most industrial ones, contain an illumination system and may be placed on a controlled environment. So illumination is because in the clear illumination, the images found, they will also be clear. So furthermore, a complete system includes many accessories such as camera supports, cables, connectors. All of this form a part of computer vision system. Now coming to the applications of computer vision system. So one we have already discussed, in the robotics. Okay, now some other section as well, other sectors as well, where we are using this computer vision. So this covers the core technology of automated image analysis, which is used in many fields. So machine vision usually refers to a process of combining automated image analysis with other methods and technologies to provide automated inspection and robot guidance in industrial applications. So industrial sector as well, guidance to the robot, just as we discussed. Okay, so in many computer vision applications, the computers are pre-programmed to solve a certain task, but methods based on learning are now becoming increasingly common. So some of the examples where we are using the computer vision system. So like one is the automatic inspection. So this could be in a manufacturing application. Then another application could be assisting humans in identifying tasks, okay, like a species identification system. Then controlling process. So this could be an industrial robot. Then detecting events. So example for visual surveillance or people counting. Yes, in restaurant industry. Okay, the next interaction. Okay, so as the input to device for computer human interaction. Interaction between computer and human. We can use this computer vision. Then next is the modeling objects or environments. So this could be in the medical image analysis, topographical modeling. The next is the navigation in the autonomous vehicle or the mobile robots, and organization information. Okay, this could be for indexing database of image and image sequences. So a large number of applications are there for the computer vision system and a good involvement in the field of robotics as well. So in the human body also we can see the vision or the eyes. They give a very clear idea of the environment as compared with other senses. So here also in the case of robot, the vision sensors, they give a much better idea of the environment. Now, one more concept inside this technique of the system, that is the image processing. So the image processing is a method to perform some operations on an image in order to get an enhanced image with a quality that is improved of the image, so more data can be collected from the same image. So it is a type of signal processing in which input is an image and output may be image or characteristics or features associated with that image. So nowadays, image processing is among rapidly growing technologies. So it forms core research area within engineering and computer science disciplines too. So image processing basically includes three steps. First step is importing the image via image acquisition tools. Next step is analyzing and manipulating the image. And the third step is output, in which result can be altered image or a report that is based on the image analysis. So there are two type of methods used for image processing. So one is analog and next digital image processing. The analog image processing can be used for the hard copies like the printouts and photographs. The image analysts use various fundamentals of interpretation while using these visual techniques. On the other side, the digital image processing technique help in manipulation of the digital images by using computers. So something just we discussed in the case of robots. So the three general phases that all type of data have to undergo while using digital technique are pre-processing, the first stage, then enhancement and display, then information extraction. So the three stages are pre-processing, enhancement and display, then in information extraction. So image processing allows the user, okay, this I think won't be visible. Okay, but it enables the user to gather higher information from the same image. So image sharpening and restoration. The common application of image sharpening and restoration are zooming, blurring, sharpening, grayscale, conversion, edges detection, then image recognition, image retrieval. So sometimes, so this type of examples are image sharpening and restoration. Then next is the medical field. The common application of medical field are gamma ray imaging, PT scan, X-ray imaging, medical CT, UV imaging. Next is the remote sensing. So it is the process of scanning the Earth by the use of satellites and acknowledge all activities of space. So we can keep a view on the Earth as well as in space as well using the same technology. So next is the machine or the robot vision. So it works on the vision of robots so they can see things, identify them. So next, the characteristic of digital image processing. It uses software and some are free of cost. It provides clear images. Digital image processing do image enhancement to recollect the data through images. That is used widely wherever in many fields. So everywhere in many fields. So it reduces the complexity of digital image processing and it is used to support a better experience of life. Now coming to the advantages and disadvantages of digital image processing. So advantages are the image reconstruction. So for CT, MRI, then SPCT, PET. Then the next is image formatting. So this multiplying, multi-view reconstructions. Then fast image storage and retrieval. After that, fast and high quality image distribution. Then controlled viewing. Now the disadvantages, so it is much time consuming. So next disadvantage, it is very much costly depending on the particular system. So this is from the economic point of view. If our system that is feasible after using the uh, this technique of image processing, then we can implement this. Okay, next is the qualifying person. Qualified persons can be used. There's one more issue that everyone cannot use it. Only we need a skilled person.